Hello everyone. Today I am going to explain how Lissajous figures are drawn and what are Lissajous figures. So first let us come to what is Lissajous figure. So you know that when we have a simple harmonic motion acted upon on a particular body, then it will undergo to and fro oscillatory motion in which the restoring force will be proportional to the negative of the displacement. And if we apply two simple harmonic motions simultaneously on a body, and if the two simple harmonic motions are parallel to each other, then the amplitude and resultant motion will change considerably because of the superposition. And sometimes if the two harmonic motions are in same direction, then sometimes depending on amplitude and phase and all and frequency, depending on that we have variety of resultant vibrations. But if the two simple harmonic motions are at right angles to each other, so completely different phenomenon is seen because then the vibration changes quite a bit, and the resultant figures which are formed due to superposition of two simple harmonic motions at right angles to each other, they are called the Lissajous figures. Sometimes Lissajous figures are in the form of straight lines, sometimes they are in the form of ellipse, sometimes they are in the form of circles, and sometimes they are in the form of some elliptical loops, etc., etc. And sometimes they become very complex also. We will see them, few of them, and we will first take very simple examples of Lissajous figures. Okay. So let us take the example of two simple harmonic motions acting at right angles to each other. First one we have taken x equals to a sine of twice omega t, and the second one y equals to a sine of omega t. Here for simplicity purpose we have taken the amplitudes to be equal, the frequency of the first one to be twice the second one, and they are having no phase difference, and so that both are starting simultaneously from the origin. Alright, so let us see what will be the nature of their resultant due to superposition. Okay, so so that we can map the two vibrations simultaneously, what we have done, we have plot the x vibration along this direction and the time axis along this direction. Then y vibration we have plot like this, time axis as this this one. Okay, and then we have drawn the two vibrations where both are sinusoidal. The difference is that this is having the frequency twice as the second one. Okay, so here during the time that this one completes two cycles, this one completes only one cycle because of the frequency. Now let us see point by point superposition. Okay, at the starting point, this is the position here, this is the position here, and if we move from here towards left and from here towards the downward direction, we meet at this point, so that this is the starting point. We call it 0. We mark it as 0. Next one is here time equals to t by 8. This point, time equals to t by 8. So and the corresponding point of this vibration is this one, this one. So the next position, the next point of intersection is this one. Okay, this is t by 8, and here this is t by 8, same time. So this is the next position, so we mark it as 1. So next position is here, it is corresponding to t by 4 of this diagram. So it is t by 4, and here the next position is this one, right? This time and this time is same. Okay, so this is the next position, mark it as 2. The next position for this one is this, and for this one is this, so they are meeting at this point, 3.3. The next position of this one is the half cycle of the Y vibration, and by that time the X vibration completes full cycle. So this is the position. So here they meet at this point again. So that is the starting point, that means, right? So here half cycle is completed, here full cycle is completed. So this the loop is completed, right? From 0 to 1, 2, 3, and it comes back to 0. The next position is here, this. And on the other one is this one. So it comes to point number 5. Then next point of intersection will be this one, and the corresponding point here is this one, right? So it is point number 6. So next point here is this, and for this one is this one. So they will meet at this point, point number 7. And the final point is here, 2 loops completed, here only 1 loop completed, so they will meet at this point O again, right? That means the second loop also completed, right? So from 0 it will come to 5, 6, 7, and it will come back to again 0. Okay, so this way we have got 2 complete loops which are here elliptic in nature, and more precisely it will be more circular, because the amplitudes are same here. Okay, these 2 loops together is the Lissajous figure for the superposition of these 2 vibrations which are acting perpendicular to each other. Okay, so this is one very simple example how you can find out what is the resultant vibration and how you can draw Lissajous figure. Okay, so similarly you can draw as many perpendicular vibrations as you know. All vibrations you can represent in terms of Lissajous figure. Take another example. This, if you see this one, the phase, this one and this one, they are superposing at right angles to each other. So their phases are same, no phase difference. They are starting from the same moment, and here the frequency is identical, right? By the time this completes 1 cycle, this also completes 1 cycle. So in that case, you again, if you follow the same procedure, how you can find? So here the corresponding point of this one is the corresponding here is this one. So they will meet at this point. So this is the first point, second point. So that means it will follow a straight line like this. Then next point here is this one, and here is this one. So it will again come back to this one. So it will go here from 0 to this point, again come back to 0. Okay, so next point here is this one, and here is this one, right? So they will meet at this point. So that means from here again it will go to this point, again finally it will come back to this one. Here it completes 1 cycle, so they are meeting at this point. So that means it is coming back. So the trajectory is a straight line. Okay, and you know this from theory, that if the 2 vibrations are having same frequency, so here, this diagram will be corresponding to equations x equals to a sine omega t, y equals to again a sine omega t, but acting at right angles to each other. Then the corresponding trajectory or the Lissajous figure will be a straight line. Similarly, you can imagine this one also. Here what we have taken, these 2 vibrations, x and y vibration, they are having a phase difference of pi by 2 here, right? Pi by 2. That means after a phase of pi by 2 only, this y vibration has started. Here the x vibration has started already, this has not started. When this here you reach this peak point, then only the y vibration starts. Okay, so then try to find the Lissajous, try to draw the Lissajous figure here also. Here the corresponding point of this point in this one is this, right? So find the point of intersection. So this one is going to be the first point, right? Here. So next here, this point corresponds to this point, right? So they will meet at this point. Again, next point here, the corresponding point here is this one. So they will meet at this point. So here the final point here, it is not the final point, it's this point, right? So they will meet at this point. And here, when it completes one cycle, then it will again come back to this point. Okay? So this way it completes one circular trajectory. That means the Lissajous figure is in the form of a circle. Here the Lissajous figure is in the form of a straight line. And here it is in the form of two loops. And so many other Lissajous figures you can draw if you know the equations. If you know the constituent equations, you can draw all the corresponding Lissajous figures. Okay? So Lissajous figures basically means that whatever figure you get by superposing two perpendicular simple harmonic motions, that is Lissajous figure. Okay? And now you can also find the frequency, ratios of frequencies by looking at the Lissajous figure only. Okay, that means you can do the reverse thing also. We can go the reverse way also. That means if you are given the Lissajous figure, you can find out the ratios of the frequencies. Here, if you take this diagram, see, if you imagine your axis to be this way, so here along y-axis we have 2 points of intersection and along x-axis 1, right? So that means what is the ratio of x frequency and y frequency? It will be just opposite. The formula is that nx by ny equals to py by px. That means frequency of x vibration divided by frequency of y vibration is equals to number of intersection with the y-axis and divided by number of intersection with the x-axis. Here this ratio is py by px is what? Py is 2 and px is 1 along the x-axis. It is having 1 point of intersection, so you can find out the corresponding ratio. Take this example. Here also you can find out what are the points of intersection. If you imagine your axis to be this one, so 1, 2, 3, here 1, so the ratio is 3 by 1. Then again, if you imagine the axis to be this one, so you have 1, 2, 3, 4, 5, 6, and this one 1, 2 along x-axis. Okay, so again 6 by 2 is equal to 3. Okay, so this way we can find out the ratios of x and y frequencies. That means the constituent simple harmonic motion frequency we can find out. Okay, so that's all for today.